G'day folks, this is a Ford automotive air conditioning compressor. It's a type of compressor I haven't really done a video on yet, so I figured it was about time. It's also a style of compressor that I haven't done yet called the wobble plate compressor. And basically it just uses a gang of pistons on literally a wobbling plate. The plate oscillates inside the housing, pushing and pulling each of the piston assemblies through the bores. Obviously I'll be able to demonstrate that once I get it apart. It's a fairly large unit. Uses a serpentine belt pulley instead of the normal C-belt. It's all full of gunk and dirt at the moment. I just washed it down, but it's been someone's junk box for so long it's just full of crap. Basically when a call for cooling is made by the operator of the vehicle, 12 volts is applied through this connector here, and the stationary electromagnet inside this pulley pulls this clutch plate onto it so the two can turn at once. Otherwise this pulley is just freewheeling when there's no call for cooling. This is actually connected directly to the pump shaft. So far I've got the main drive plate and pulley off. That means with this circlip and a retaining nut on the shaft. This is the serpentine pulley with its idler bearing. Pretty shagged. These are just a steel on steel pressure plate. There's no material on it like a brake pad or anything. And once this electromagnet here is energized, it basically magnetizes this pulley, which then attracts this clutch plate, which has little leaf springs in there, independent of the center, and pulls it into contact and provides enough drive for the compressor to do its thing. With the electromagnet removed, I found a little, I suppose, oil wick made out of felt in here at the bottom, and the presence of this congealed refrigerant oil on the housing indicates that these must bleed a little bit of oil out of their main bearing, obviously as a part of the lubrication system, and in doing so I guess they lose their gas that way. Probably why automotive air conditioners require regassing after a while. Screw bolts seem to hold all 4 sections together. They go right through to this end housing. You can see why these things leak. These go straight into the crankcase. Probably not approved by the EPA anymore. That is the front housing, gasket. There's passageways. Shaft key to go with the drive plate. The keeper is simply stuck. It's a 3-cylinder wobble plate. These are the inlet valve, and these are the discharge valves. Not sure if you all can see that, but I hope this first chute works out. Another set of valves here. Look at that. It's double-ended. Never seen that before. Two sets of valves. It looks like it's a double acting pump. Maybe a little bit different to the old wobble plate design. A big hole. That's interesting. I've never seen one like this before. Here, not sure what you would call this kind of compressor. It's definitely not a wobble plate. Each of these little piston modules has two little ball bearings and bronze keepers in them, and it uses this eccentric here to slide them in and out. Thing doesn't work so well when it's apart, but that's basically it there. Bugger. Little wear plates like bronze or copper. Teflon seals on either end. I suppose you'd call this a double acting wobble plate compressor. Thrust bearings on the end of the shaft. Very interesting. Definitely not what I expected, but still a form of wobble plate compressor. Not sure what the technical term for it is. I looked it up last night and just can't remember at the moment. And there you have it. I know you can use these as conventional air compressors, but they do require a bit of oil and maintenance. A bit louder than a hermetic air conditioning or refrigeration compressor anyway. I didn't capture the valves properly on that first take, so here's a retake. This is the inlet side, the piston 1, 2 and 3. As the piston goes down the bore, this one opens up like so, and gas is drawn into the chamber. As the piston goes back up the bore and compresses it, this one's pushed shut, but it's forced out through this discharge valve here into this chamber. And this is the high pressure, high temperature gas discharge chamber, and this is the low temperature, low pressure suction gas chamber. Likewise on here, as you can see, S is suction and D is discharge. The discharge line's coming from in here and the suction line in here. Down the side, that's suction line in there, and that's discharge on the outside. I've never seen one quite like this before. The other design that I've got involves all of the pistons on one side and just being dragged in and out the bores. This is the type of single acting compressor I was referring to earlier. This is one of the display pieces that I have at the moment. It's from a AC Delco type Japanese built compressor. I scrapped it a long time ago, long before I got the camera. And basically it just uses a single crankshaft, single thrust bearing, and this plate is kept stationary by this keeper here in the housing, but it's still allowed to drift up and down. And obviously the pistons are pushed and pulled through the bores accordingly. They don't actually have a gudgeon pin or any kind of conrod, they're actually ball jointed and can rotate. Also ball jointed at the bottom. Kind of a weird little contraption, but they work quite well.